Hello everyone, it's me Arvin catching you on another Math Tutor Edu's lecture video. Okay, in this lecture video, I'm going to discuss application of differentiation part 2. Okay, by the way, we are still discussing the application of differentiation and I've already completed my part 1 discussion. By the way, if you haven't watched the part 1 discussion, so please click on the link above and watch that video first. Okay, so without further ado, let us start our discussion for the part 2 now. So in this part 2, I'm going to discuss the turning points, maximum point and the minimum point. So as you can see here, you have two types of graph A and graph B. Okay, basically they are both a quadratic curve. It's just the different type of the curve. Okay, one you have the smiley face, another one is the sad face. Okay, the difference between two is the coefficient A. Okay, the coefficient A for the graph A is more than 0, whereas the coefficient A for the graph B is less than 0. Okay, and that's how it differs the shape of the quadratic curve. Okay, so how we can relate these turning points, maximum point and minimum point, through this two type of graph. Okay, I'm going to show you now. So as you can see here, for graph A and graph B, they have a similarity. What is the similarity? They both have turning points. Okay, where is the turning point? The turning point is exactly over here, at the tip of the graph. So this is the turning point. Okay, so let me just write here turning point. Okay, so this is your turning point. Okay, so let's say I wanted to find a gradient of curve at the turning point. So what I'm going to do is I'm going to draw a tangent line at the turning point. So what I'm going to do is, okay, let me choose a different ink. Okay, and draw the tangent for the graph A and graph B. Okay. So as you can see, graph A and graph B, the tangent line is perfect horizontal line. Okay, if it's a perfect horizontal line, that means your gradient will be 0. And since we are calculating the gradient of tangent, so what is a gradient of tangent known as? It is dy over dx. Okay, you can call it as gradient of curve or gradient of tangent. It is the same, guys. Okay, so since we are calculating this, the dy over dx, and it's a perfect horizontal line, so your dy over dx will be equals to 0. So in this case, your dy over dx will be equals to 0 at the turning point. Okay, regardless it is a smiley face or the sad face. Okay, dy over dx is equals to 0. So this is one of the important terms that you should remember. Okay guys, turning point. Okay, whenever you see in the question turning point, you should know that your dy over dx, your gradient of tangent, will be equals to 0. Okay, why equals to 0? As you can see here, you have a perfect horizontal line. Okay, gradient of a horizontal line always equals to 0. Okay guys, so you should remember that. Then that's why you have your dy over dx is equals to 0 for the graph B and the graph A. Okay, so that is the concept for turning point. So as you can see here, you have maximum point and minimum point. Even though these two graph has turning points, but then they have their own special points. Okay, the one will determine whether it is a maximum point or a minimum point. So let's take a look at the graph A. If you take a look at the graph A, as you can see here, it's showing at the minimum point. So this point is actually a minimum point. So from here, so here it shows that a minimum point. Okay, and for the graph B, over the turning point here, it's showing a maximum point. Okay. Of course, I'm showing you through the diagram. It is easier for you to a check. But then in the calculation, so how are you going to determine whether the turning point is a maximum point or a minimum point? So I'm going to summarize all the formulas and I'm going to explain it to you now. Okay. So whenever you see a turning point, so at a turning point, so remember this always, your dy over dx will always be equals to 0. Okay, and this is the explanation why it always equals to 0, guys. Okay, at the turning point. So let me box this, and please remember this. Okay, so this is for the turning point concept. Okay, once you already find the turning point, the next step is you need to check whether they are giving a maximum point or minimum point. So how to conduct the maximum point or minimum point? Remember, in the concept you're learning in the differentiation, you have learned about the second derivative. Okay, and that second derivative you're going to apply here to check whether a point is a minimum point or a maximum point. Okay, so let us start at the maximum point first. So at a maximum point, okay, so how to find the maximum point? So you need to perform double differentiation, or you need to perform the second derivative. So in that case, your d square y over dx square. So you need to perform this differentiation for 2 times, and this answer you should get is a negative value. Okay, you should be a negative value, or to make it simple for you, it should be less than 0. Okay, less than 0 means of course it's all a negative value. So if we in case for example, so you perform double differentiation, let's say you get negative 25. So then you can conclude that that turning point is actually giving you a maximum point. So let me box this. Then you can ask me, so how come it can give you a negative value? Take a look at this graph B. The coefficient of A is a negative. So when you perform double differentiation, so it will give you a negative constant. Okay, so can you get the concept? So that's how you get the negative value over here, and from there you can conclude that it is a maximum point. Okay, so let's move on to the third concept. So at a minimum point, so your d square y over dx square should be more than 0. For maximum point, less than 0. For minimum point, more than 0. Okay, so that is the only difference. Okay, why more than 0? Take a look at the graph A. So your type of graph A is a smiley face. Okay, smiley face, the coefficient of the quadratic equation for the coefficient A is always more than 0. That's why when you perform double differentiation, you always get a positive value. Okay, when you are having a positive value, so you can conclude that it is a minimum point. Okay, so I hope you understand. So this is the quick explanation regarding the turning points, maximum point and minimum point. Okay, so now I'm going to discuss you one example. So let me read the question now. Okay, by the way, you will see the question through the image form shortly. By the way, I'm going to read it through the question from the book over here. So let me read the question now. Find the turning points on the curve y equals to x square minus 6 times with 2x minus 3. Determine whether each turning point is a maximum point or a minimum point. So that is the question. Okay, so this is the question. So let us solve this together. So I'm going to teach you how to solve this question. Let us start to solve this question together. Okay, so just give me a moment. Alright, okay, so to start off, let us write down the y equation. So in the question given that y equals to x squared minus 6, okay, close bracket, 2x minus 3. Okay, so let us expand this. So from here you get your y equals to, so x squared minus, x squared times 2x, that is 2x cubed. So x squared times negative 3, so you get is negative 3x squared. Negative 6 times 2x, you get is negative 12x. Negative 6 times with negative 3, so you get is positive 18. Okay, so this is your step 1, guys. So once you're done with your step 1, so the next step is you perform the differentiation with respect to x. So from here, dy over dx is equals to 6x squared minus 6x minus 12. Okay, so when you differentiate this, so this is what you're going to get. Okay, and since the question asks us to find the turning point, so the condition of a turning point is dy over dx should be equal to 0. So you write down in the working at the turning point, okay, so from here dy over dx is equals to 0. dy over dx we already find is 6x squared minus 6x minus 12. So you just substitute this expression over here. So from here 6x squared minus 6x minus 12 equals to 0. Okay. So before proceed to the factorization, let us simplify this quadratic equation by dividing the whole equation by 6. So from here, you're left with x squared minus x minus 2 equals to 0. Okay. So factor out the 6. So let us perform the factorization for this quadratic equation. Okay, let us set the mode to equation and let us set this to quadratic equation. So quadratic equation, just click number 3. Okay, for the coefficient A is 1, coefficient B is negative 1, coefficient C is negative 2. Okay, so you get x equals to 2 and x equals to negative 1. So when you are writing this in the working, it should be other way around. Okay, so 6 in a bracket, x minus 2 and then x plus 1 equals to 0. So from here you get your x equals to 2 and x equals to negative 1. Okay. This is your x value for the turning point. Okay, once you already find the x value for the turning point, next what you need to do, you need to substitute this x value into the y equation over here. Okay, and then later once we get an x and y value, so it will be a coordinate, right? So to check whether the turning point is a maximum or a minimum point, so we need to perform double differentiation. Okay, so for that we're going to start with the x equals to 2 first, and once we done x equals to 2, then we proceed with x equals to negative 1. So let us start with this first. When x equals to 2, so from here y equals to 2 square minus with 6 Okay, and then times with 2 times with 2 minus 3, close bracket. So you calculate this, you should get your y is equals to negative 2. So therefore 2, negative 2 is your first turning point. Okay. So to check whether this turning point gives a maximum value of, maximum point or a minimum point. So from here to check. So from here, let us perform the double differentiation, d square y over dx square. So when you differentiate dy over dx for second time, so you should be getting 12x minus 6. Okay, so from here, you substitute the x equals to 2 over here, this double derivative equation. So from here, when x equals to 2, so from here you get your d square y over dx square is equals to 12 times with 2 minus with 6. 12 times with 2, you get is 24. 24 minus 6, you get is 18. So 18 is literally more than 0. Okay, since the value is more than 0, therefore we can conclude that turning point (2, negative 2) is a minimum point. Okay, we already done with the x equals to 2. Let us proceed with the x equals to negative 1 now. Okay, let me just split. Okay, when x equals to negative 1, so from here y equals to negative 1 square minus 6, okay, close bracket, times with 2 times with negative 1 minus 3. Okay, you solve this, you should be getting your y equals to 25. Okay, excuse me guys. Okay, therefore negative 1, 25 is your second turning point. Okay. So once you already find the turning point, so we need to check whether this turning point is a maximum point or a minimum point. Okay, so to check, okay, so from here let us perform the double derivative. Let us do the calculation. So d square y over dx square is equals to 12x minus 6. Okay, so you substitute the x value over here. So from here, when x equals to negative 1, so from here d square y over dx square is equals to 12 times with negative 1 minus 6. So from here you get your d square y or dx square is equals to negative 18. Negative 18, it is less than 0. Since the value is less than 0, so from here we can conclude that turning point negative 1, comma 25 is a maximum point. Okay. So this is your full working, guys. Okay, we have already find the turning points, and within that turning point, so we need to determine whether it is a minimum point or a maximum point. Okay, so these are the full working, guys. Okay, that's why I split it into two, since we have two x values. So this is for the second turning point, and this is for the first turning point. Okay, so I hope I made this clear. Let me scroll this up. Okay, that is all for the lecture video for today. So I hope you understand the concept of turning points, maximum point and minimum point. So if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and not to forget to share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.